Good morning, Miss Clinton.
Sammy, here's your original test that I didn't give you back yesterday.
Amanda,
Yes.
can you hear me?
Yes.
Amanda?
It looks like the video quality is jumpy again, though. The sound is great, but the video, it like turns orange and blue and pixelated. Are you there?
Is it on mute?
Joe?
Brittany's typing.
Joe, are you there?
This class involves so much paper. I'm going to drown. Because I have like 3 copies of everything. No, 4 because the corrections.
Joe, are you over there?
I really need to get homework to go. Starting from
Joe?
No, I can't hear you. These are so weird.
Davidson, can you hear me?
Yes, I can hear you.
Okay.
Is the feed any better than it was yesterday?
Let me go back to the camera. It was being very, very pixelated.
Okay. This is Chad at Network Control in Research Triangle Park. I'm monitoring your call, your video connection.
Okay.
So isothermal, you guys are pixelating pretty bad.
Sammy, if you can hear me, wave your hands.
I can hear you.
Okay, cool, thank you.
Davidson, if they cannot hear you or hear me, if you will type to them again. Excuse me.
Can you hear me now?
If you'll type to them again, them that they need to disconnect and reboot, and then connect back.
Okay.
All right. Disconnect, reboot, and connect back.
Okay.
How do you spell pixelated?
Okay, I'll do that now.
That's okay.
This is
Thanks.
doesn't matter.
There we go.
Apparently to Gavin, he counted off 1 point on my spelling on our first test.
Really?
Yes, he did. Why? I don't know. I was. He's like, I think you're not really English. It's like, I correct my grammar. I'm in trouble. So they can hear everything we say.
So who
And
is
they
this
can
other?
watch us.
He's from Chad is in Raleigh.
Okay, this is like a.
I wonder if
Chad is, well, I don't know if it's always Chad, but this Chad is the guy that gets us connected.
Oh, no.
Chad,
Yep.
where did you go to school?
Yeah, I'm in Research Triangle Park.
Isn't that cool?
Ask him. Ask him.
Are there any jobs open in Research Triangle Park?
What school did you go to?
Oh, what school did you go to, Chad?
Many, many, many moons ago, I went to Appalachian State.
Nice! Go Appy!
Yeah, hold on just a second. Let me get the phone here.
So is he gonna fix all our problems?
Yeah, is anyone else a little frightened that there's people we can't see that can hear and see us?
Just a little.
It's like a stalker. It's like, I didn't realize he was on and he just started talking about
What is this for?
Pick up whatever one you want. That's when you hang up.
That's what the star.
That's what the star means.
Did you do that work last night?
Did
I
you
thought
do
we
it?
didn't complete. We didn't
So,
finish.
Chad, are you still there?
I didn't do the homework the first night.
It looks like our video is still pixelated without them.
Last year.
Okay, I'll look into that. You look, your picture looks fine coming to me.
Yeah.
No, I'm not talking to you, brother. I'm not talking to you. I'm doing another problem at the same time I'm trying to get to you. So
Okay.
hold on just a second.
Sure.
Davison, I got another phone call that I'm trying to deal with right at the
Okay.
same time I'm doing you. So, yeah, let me take care of Fayetteville and I'll come back to you.
Okay.
I'm supposed to have those ones.
Part 1 on Super Bowl.
Well, he's waiting on the other side to connect again.
Part 3 and 4 yesterday. There's none of those shows air on Wednesdays. I don't know.
I know, I feel like maybe I should reboot because it's still doing that
filmed it.
without them being connected.
Because then they gotta get back to their actual shows.
And those are just behind the scenes.
I don't think so.
For preview things. I'm so excited. It's so good. They are annoying with all their commercials in between you watching this.
Because this the video show, Sammy.
It's a what?
It's a CW
I know,
show.
but they need to just be quiet about it. Leave me alone. I have my own show to watch. That and I spent last night watching the Super Bowl. Or no, why did I say Super Bowl? The Steelers versus Packers game. We're on our way to the Super Bowl. This year,
Really?
yeah, this year we need to win the Super Bowl for the 7th time, and then we're good. You know, like the expression
that
"stairway to
fast.
heaven." For Steelers, it's
I did
"stairway
better
to
than the
7."
others. Someone's so good. I
That
just,
means you'll get
will
all
you
the
see me
Like,
talking?
the Steelers versus Packer game was played on Sunday.
Okay, let's see if this is any better.
Can you hear me?
Yes. Yes, can you hear us? Joe?
Silence.
I don't think that's gonna work. I'm definitely not muted.
Yeah, and I can hear
Should
you.
I
and
reboot?
Taking control.
I can hear them too.
There they go. Do you want to use this today, or? Because I got to wait on him that we're.
They can hear us.
Okay, so the video is fine.
Yes.
And we've been
The
having.
audio is pretty much fine because I can hear you. So if they hear you, it's an issue on their end, and they need
They
to
can hear us, we can't hear them.
Can you hear us now? Wave a hand.
type to
We
them
can
and
hear
tell
you.
them
Still
that.
there?
Can you hear us?
They can hear us. Is the
We can
video
hear you.
quality better?
Kinda. No.
Video is
No.
better to me.
I mean, the
I can't
video
hear
looks.
you. Sorry.
Yeah, a little bit of
Is the
pixelization.
video quality better or worse?
Man, the movie.
Zoom in and see. Oh.
Go ahead.
Zoom. I'm thinking it's about the same.
Guys, we gotta have codes in case this happens. This is Zoom. This is shrink. To the right, to the left, up. The way you.
It's gonna dance.
They probably think I look really stupid because they.
Oh, she got the memo.
And then
Send your signals.
sometimes we just need to throw in weird news.
I think Chad
Davidson.
might be sending our signals.
Davidson, if you'll type to them and tell them that the audio issue is probably on their end.
So do I need to reboot on our end?
No. You're fine. I've got video and audio from you, and you're good.
Okay. Okay.
The,
I'm cutting out early.
the pixelization from their end is probably network related down there at their end, like the local area network down there. The audio issue is probably maybe a routing issue down there in their room. So if you can type to them like you did just a moment ago.
Well, it seems like even when they were not connected to us, it was still being pixelated though.
Yeah, and I don't know if that's see.
Very jumpy feet.
I don't know what that's about.
It happened so quickly.
What did you want me to type to them?
Yes.
Yeah, solar flares or something. That's correct. We cannot hear you.
I don't want to.
We've rebooted 3 times, and I've called the sound technician. So we are working on it on our end, but
Okay.
we go ahead with class while we're. It's as long as you can hear us and then type your questions in there.
Okay, that'll work. That'll have to be the way that you do things.
Okay, so guys, if
Okay,
you have
thank
any
you.
questions,
As far I know you, is the video feed better than it was yesterday?
You have the version was great.
tell her to maybe check with her IT folk about the video.
It's jumpy on this end too. Yeah, can you drag that file about our video? Okay, yeah, they're on their way now, okay?
Okay. How do I put an emoji in here?
I think you go to insert and then you can do special characters.
We're going to go ahead and try to start, and hopefully Davidson can
Thanks, Davidson.
make as much out as I can. Hopefully, I hate that it's still a mess. I put on the board here kind of a summary of what we've already discussed in preparation for going through the proof of the fundamental theorem of calculus this morning. So I've restated the fundamental theorem up here. F is continuous on the closed interval A to B, and capital F of x is an antiderivative of little f of x. Then we can state that the definite integral from A to B of f of x dx is equal to capital F of B minus capital F of A, which is also equal to the evaluation from A to B of the indefinite interval of f of x dx. And then to try to tie those together, why, again, why it's called fundamental theorem, I went kind of restated the definition of definite interval as the limit n goes to infinity of the Riemann sum. Identify if that's a signed area we're talking about, and emphasize that as n goes to infinity on this definition, the delta x in the definition goes to 0 because delta x is b minus a over n. So on the definite interval business, the delta x is going to 0. That limit is important to us. And then on the indefinite interval, which is an antiderivative, which is just undoing the derivative, and we've already discussed, just spent a good bit of time talking about the derivative, which again involves the limit as delta x goes to 0. So in both cases, we're applying this idea of shrinking the horizontal change to 0 and examining how it affects two different things. On the one hand, we're examining the rate of change and how that's affected by shrinking the horizontal distance to 0. And on the other hand, we're examining the area under the curve by shrinking rectangle widths to 0. And the fundamental theorem links those two very disparate concepts, links them together for us, and thereby provides a shortcut for calculating the definite interval. Rather than having to do the actual Riemann sum, you can simply find the antiderivative and evaluate at the endpoints. So then I've included a graph, like we talked about yesterday. These are just two random functions. I'm not proposing that this capital F is really truly the antiderivative of that little f, but I'm just using them as examples. So this is my little f of x function that's you're seeing over here. And then I'm saying or pretending that this green graph is the antiderivative function from the indefinite interval. And the red highlighted area underneath little f is the definite interval we talked about. And then the change in the endpoints of the antiderivative, that change in endpoints, called the net displacement, is equivalent to the area under this function here. And so I've gone ahead and set up the partition, the subintervals x0, x1, x2, like we've done before, because we'll need that when we get ready to actually work on the proof of that. So that's just a review of what we've covered, and again, emphasizing one more time the importance of this theorem in terms of linking two very different concepts together. And now we just want to try to prove it. So I'll give you a minute to copy that down, because on a test, besides being able to use the fundamental thermal calculus and prove the fundamental thermal calculus. I think we'll discuss it. What does it mean? Why is it important to us? So that's the background of it. Of course, the video, if the video recording is any good, you can see that on video recording as well. You can always watch the video. So everyone, okay, so I'm going to start the proof now. We're going to assume the hypothesis. So assume f of x is continuous on A and B, and capital F of x is an antiderivative. Okay, so we're just going to try to come up with a sequence of steps that converts the definite integral. We want to start this left-hand side, the definite integral, which you can't see on the screen now, but the left-hand side definite integral, we want to start with it and then convert it through a series of steps until we get capital F of B minus capital F of A as the final result. So we'll start with so starting with the left-hand side, first thing we're going to do is write what we know that means. Okay, what does it mean? We just had it on the sideboard. What is it defined as? We have to have something to work with. Right. So we're going to use that definition. So we're going to just convert it to the definition. So by definition of definite integral, we converted this symbol to what we defined it as. That's fairly simple. Next step, I want to involve capital F somehow, because that's what the theorem does. It uses capital F. So I'm going to replace in the definition this little f with a capital F. But it's going to have to be capital F prime of x of k star. Why can I do that? What allows me to make that substitution? Right here, back on the previous board, the definition of indefinite integral is that f prime of x equals little f of x. So that's simply by definition of indefinite. That was easy. Now, because capital F is an antiderivative, then it means that, by definition, that the derivative of capital F is little f. That means that capital F is differentiable. Because we already have the derivative. It is differentiable. Mm-hmm. So because capital F is differentiable, then that means it's also continuous. There's a theorem that says if it's differentiable, then it's continuous. And therefore, we have a differentiable and continuous. So the mean value theorem applies. It's your capital F. The mean value theorem we talked about yesterday required that it be differentiable and continuous. So it is differentiable because we were already talking about it being an antiderivative. And if it's differentiable, then it's continuous by theorem. And that means I can apply the mean value theorem. And therefore, I'm going to let x sub k star equal c sub k by the mean value theorem. So what do I mean by that? Okay, so back over here, we have to pick an x sub k star in each subinterval. So you got all these little subintervals, and we're picking an x sub k star in them. I'm going to pick an x sub k star for each subinterval. So look at this is one subinterval. I'm going to pick an x sub k star so that it's the special c associated with the capital F function and the mean value theorem. Remember, the mean value theorem says there's a special c so that the average rate of change across the interval is equal to the instantaneous rate of change at that one special c value. So for each of these subintervals, there is a special c that makes the average rate and the instantaneous rate be the same on each subinterval. I'm going to let my special x sub k star be that c sub k. That means I can replace that symbol by c sub k. So now I'm to this. Because I can apply the mean value theorem, I can guarantee myself that there is this c sub k. Each subinterval has a special c value that satisfies the mean value theorem, because the mean value theorem applies. I'm going to use that c value instead of just any random x. I'm going to use that special c. What does the mean value theorem say? It says that this is the instantaneous rate of change because it's the derivative, is equal to the change in y over change in x. That's right. So that means for each little subinterval, that there's this special c sub k in, and the tangent slope in that subinterval has a slope to it. The tangent line has a slope to it. The slope across that little subinterval has to be the same as that. So what is that slope? Well, so the instantaneous slope has to be equal to the average slope. But the average slope is going to be capital F of the right endpoint of the interval, which is x sub k, minus the left endpoint of the interval, which is x sub k minus 1. Y'all remember all this? Yeah. Right and left endpoints of the subintervals. And then the change in the x, which is going to be x sub k minus x sub k minus 1. So I'm now converting from using the derivative of capital F to using capital F itself. So I've gone from instantaneous rate of change to average rate of change on the antiderivative function. So I've converted on this green function up here. I was looking at a special point where the tangent line, or just the tangent line, has a unique slope to it. Now I'm converting to the average slope, which is the same slope. Okay? This is times delta x.
See? See? No one has faith.
I'm going to have all of this. These two steps here were because of the mean value. Okay, I'm going to have to move over here because I'm getting too old.
Got him good.
Folks, what is x sub... I'm sorry, I get to that. I apologize.
Hello.
What is x sub k minus x sub k minus 1? What's this difference equal?
Delta x.
It equals delta x.
Couldn't
Go
even
with
hear
it?
us.
So, what does that mean over here? What can I write in place of that over here now? What's my next step?
This is starting to look
Yes.
real clean.
This is a delta x, and that's a delta x. So I can cancel it. So it's just going to become
But changing twice.
Oh crap, y'all. This is what I live for.
Proving stuff.
Delta X.
Proving stuff.
Oh, the Delta X. This reminded me of my ex.
So all we did there was cancel a delta x out of the process because it was multiplied and divided. So we just canceled it away.
Got him.
Getting close now. Almost done.
It looks so familiar.
So what does this mean now? Let's go through the detail of what all that means. We're adding up a bunch of things that look like capital F of x sub k minus capital F of x sub k minus 1. Let's actually write that out. What does that look like? So when k equals 1, you're going to have f of x1 minus f of x0. And then you're going to go to k equals 2. You put in k equals 2, you're going to get f of x2 minus f of x1. Then you're going to go to k equals 3 and so on. And when you get to k equals n, you're going to stop. And the last pair that you're going to get is f of x of n minus f of x of n minus 1. So you're doing the limit as n goes to infinity of this. This is what this summation expands out to look like that. What can you see there now?
I'm seeing something.
Sammy, do you have a question or a comment or a suggestion? Chloe, do you have a?
I'm sorry, Chloe.
No. Okay, well,
That's great.
first of all, since this is all addition and or subtraction, all of these grouping parentheses could go away by the associative function. And then if you imagine all the parentheses gone, what do you see? Well, I got a f of x1 right there, and I got a negative f of x1 right there.
Hey.
See that?
I wasn't ready for that.
And then I have an f of x2 right here, and if I had written another, let me add another term in just so you can see better what's going to happen.
What is wrong?
So this is going to be f of x3 minus f of x2 plus dot 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 plus f of x n minus f of x sub n minus 1.
So we're going to do this.
Okay, so I have an f of x2 right there, then a minus f of x2 right there.
Got him.
So the
And if you go all the way across this process, you'll cancel out all of the terms.
Everything.
This x n minus 1 with a minus sign will cancel with one right before it, right back here. The only thing left standing after all of that cancellation will be
This is my mama.
negative f of x sub 0 plus
That's it.
f of x sub n.
What's wrong with you?
nothing. Everything's fine.
I like your notepad.
How does it feel like we still have a gun?
We have it now, folks.
We're so close, y'all.
Let's see. X sub 0, according to the graph way back on the first board, x sub 0 is equal to A, and x sub n is equal to B. So this is simply the limit n goes to infinity of, and I'll put the minus second because it just looked better. So capital F of B minus capital F of A.
I love it.
Are we done?
No.
Well, now what? Limit n goes to infinity. Well, folks, capital F of B is a number. That's a function of a fixed number, so that's a number. And f of A is a number, so n going to infinity does not affect either of these numbers. They're just numbers.
Straight irrelevant.
So the n goes to infinity has no effect, so it just becomes f of B minus f of A, and we've got it done.
Got him good.
Little tiny square.
For my reasons, let's see, up here, this reason was I just expanded the sum. Up here, I expanded the sum. What did I do here? I guess I could just say I combined like term. Combined like
How sweet.
term. What did I do here? I replaced name of the value. And then I just did the limit.
Yo, hang on.
What does that say?
Replace name of value.
No, it says 7e plus.
There you go. Fairly simple. It does require the mean value theorem, which we mentioned yesterday. So questions on this, anyone?
It probably is.
After we've done it, now we can just
Like the actual group.
It probably is, Sam.
practice using it. So we
That's
need
what
to,
he said.
one more time, we need to be able to discuss the fundamental theorem, why it's important to us, be able to prove it, and be able to apply it.
You're using this
So
If
your
it
third
says
eye.
if this
applying it is easy.
is on the
Why don't y'all try one real quick?
it's on the test.
How about try number
You know,
on page 373? Let's take a moment and try number 28. Just in class real quick, just to practice. See how we're doing. We'll try that one or two of them, just to make sure we're getting it right. All we have to do is apply the theorem on this. We don't have to do any more than just simply apply the fundamental theorem. If it applies.
What does he say, number 28?
Yeah.
It doesn't even have that.
Number
you
28.
can't even cheat on this. What a disaster.
This is ridiculous.
Nice.
Everyone
I
good
did-
with the
I did a P
all
all three boards.
Okay, thank you. Yeah, we needed all three boards. I'm going to leave this one because I don't want to have to redraw that one in a second class. So I'm just going to erase this. Everyone good with the?
So now all we have to
I'll raise this board. I'll leave the last board over there in case somebody's on top of that.
You're writing down
The definitions.
Oh.
What is he writing? He is writing the integral from 0 to something secant x.
It's pi over 4.
We're doing 28.
Yeah, we're doing 28.
Math.
Got it. Oh yeah.
Yeah. That's what I'm doing.
I live for 28.
Can they like raise the camera a little bit?
They can raise
Did you do tangent of
Why don't they just lower the board, Brittany?
Oh wow, amazing.
Then they don't have to.
Can you ask them if they can
as would be my
bring the camera up some,
No, just tell them to
No.
lower the board.
or lower the board?
No, up, yeah.
Miss Claire, tell them to lower the board.
Can you lower the board?
Yeah, duh.
You're swear.
Last word for Joe.
And then the cord, you won't.
Can you read
show.
that?
Can you move
Can you
camera
mirror-
up a bit?
Can you mirror camera up a bit? Do you know what the camera was?
It says camera.
This is like a ancient Greek
Right,
creature.
thank you as well.
Writing into the
Keep highlighting it.
I don't think. I'll
Highlight
tell you
it.
what. I don't think he's facing.
Highlight it, circle it.
I
in
like
red.
the highlighter a lot.
Run it like 20 times.
Use the creative pen, because that matches where we are.
Oh, no. Why is it?
Thank you for filling in that little.
Now it looks like
And
a
you move the
mustard,
camera.
mustard tail.
Look how Mr. Gaddis is the one that sees it first.
Oh, it's all day, no.
Why? Who else would see
Oh,
it?
come on, why?
Who's-
But, I haven't actually done any problems. I just wrote down 3 problems. I asked you to go ahead and work on number 28.
Yeah.
While you were doing that, I wrote 2 more just from the book.
Number 30.
Got him.
Let's see how we're doing.
Got him, girl. Got him. Got him good. Got him good.
We might have an answer for number 28.
Was it gonna be tan something?
We'll have to do a Riemann sum here, folks. This is
For which one?
unknown terms. We just have to find an antiderivative
Alright, I got one.
and then evaluate at the endpoints of the antiderivative. Here, an answer equals 1. Okay? Does anybody else have 1 as an answer? Maddie has an answer 1, okay? Chloe says 1. Okay? Chloe and Maddie both say 1.
Says Chloe.
I don't know how to work it out, but it sounds reasonable to me. Joe gets a 1 also, so we got 3 people so far voting for a 1. Well, hopefully this is all right. We'll go through it. Oh, and Josh, we got 4 now.
There we go.
What was the answer?
Good answer, man.
Yeah. I saw. Why didn't I read that? I was like,
Okay,
there's a-
so for everyone else, real quickly, let's go through it, and then I'll let you work on the next one here. So just, how did you handle this?
Secant square.
You handle it.
Because
by
what I
looking-
would do is, using the theorem, this is simply the antiderivative of secant squared of x dx, evaluated from 0 to pi over 4. And by now we know the antiderivative of secant squared is tangent. So this is simply tangent of x evaluated from 0 to pi over 4. And that means we're doing tangent of pi over 4 minus tangent of 0, which is 1 minus 0, which is 1. So I agree.
Got him good.
Good. Well, now y'all try number 30 on the same set of exercises. See if you can figure that one. 50 minutes to work on it. We're gonna have to solve it.
Okay, my question is, how do you get a derivative that like makes a fractional thingy? That's my question.
Out of here. At half hour. That's good.
What, is this gonna be a natural log or something like that? Because if it isn't,
No, it's gonna be
I think it's gonna be an inverse tangent.
inverse tangent.
inverse
Inverse
tangent.
tangent? Yeah.
I'm gonna scream if it's inverse
It
tangent.
is inverse tangent.
Cursed be my fate. What was it? Inverse tangent of 4x.
No,
I think it's gotta be 2x.
Is 4 what?
it's 2x.
Gotta be
2x.
2x.
So does that mean it's 1/2?
They have to be
inverse
1/2
tangent?
of 2x.
Had to be 1/2 in the front.
Wait, so why would it be 2x?
Cause the 4 is not squared in the problem. It's
There's
already
not-
squared.
There's not,
Cause 2 squared is 4.
there's nothing on the numerator except for 1, which means you had to cancel it out because you take the derivative of the inside of the whatever you're
You got
doing.
an answer?
The two.
Hand up?
Yeah, change.
Not for you. Where does the 1/2 go?
Raj has his hand up.
Front of the tan.
No, he's just talking.
I'm not saying.
So we can't hear them.
And the video, I think.
Yeah, and the MCNs.
Are you guys? What happened here?
This is all over. No, they're still there.
No, they're playing Undertale.
Hey, whoa, hey!
Can you hear us?
What?
Okay, that's exactly what I did 3 times, Jim.
Sure you did. This got to be an IT. It's got to be IT. They have the secret button back there in the back that they know where to push.
I did exactly, you realize, 3 times I did.
Yeah, I don't care.
Sorry.
And then that's
Anyone here?
Anyway, morning.
Well, thank you, sorry.
So, do we have any answers for this one?
It's a game.
It's a really lame game.
Let me make sure that I did
4.
Oh, yeah.
Cause you just did that in the last problem.
Holy crap.
Did I hear an answer? Someone?
Oh.
Wait. Davidson? Anybody over there have an answer?
Is it a funny answer?
Is it a funny answer?
I don't know. What's funny? Is it humorous or is it just kind of odd?
It's humorous in
looking, or
its
what?
absurdity.
Wait, what?
It's humorous in its absurdity because it's not a straight up like 1-digit number.
39269.
Well, okay.
Right?
What did you get?
What'd you get?
0 is going to be
08.
Well, what's
There you go.
Carry on.
Because you have 2 pi over
You're
2.
hundred.
Thank you.
You're slowly.
So
Thanks.
Thanks.
pi over.
Wait, so what is the
What would be
answer?
2 pi? It'd be 0.
What is inverse
2 pi
The
is
question is then, what is the antiderivative of 1 over 1 plus 4x squared?
Inverse
Tan of
tangent.
2x? Is that it? Please.
It's close,
please.
yeah. The derivative with respect to x of inverse tangent of 2x is going to be 1 over 1 plus 2x squared, which is this, but it's times the derivative of the inside, which is a 2.
Oh.
Hey, the high rule, Rezo.
The high
So, so if I move the 2 to the other side, then I would have 1/2 inverse tangent of 2x, 0 and 1/2.
Dang, y'all.
Right?
We're getting straight Germanic in this piece. What's wrong about the
So this
domain?
is 1/2 of inverse tangent of 2 times 1/2, which is 1, minus 1/2 of inverse tangent of 2 times 0, which is 0.
Oh, it is going to be humorous, isn't it?
It's fun.
Is it not humorous?
1/2 of 1/4 pi minus 1/2 of 0.
Why is it? Oh, 1 and
So I guess that's 1/8 of pi. What I get?
Because 1/2 times 1 is, or 1/2 times 2 is,
But can you do
one.
that if it's in the tangent?
what?
Good question.
What'd you guys the
Oh
answer?
wait, no, I understand.
Pardon me?
Lower the
Huh?
camera.
Pi rate.
Thank you.
Pi rate.
All right, now, can you see the camera? Can you see it now?
Got a
Well, I got
decimal.
1/8 pi as an answer, right? Anybody else get that?
Pi over.
We got 1 yes. Okay, so 2 is oh yes.
And that's what I got.
Okay, so how do you, I understand now.
Okay.
My eyes have been opened.
I like this method so much.
Well, elucidate for the rest of us here. Others may have had the same issue or whatever. What was your issue? How did you clarify it?
I was stuck in a world where I was only using decimals, but then I saw in terms of pi.
Light of fractions.
Yeah. Yeah.
Light of fractions.
I see now.
See, okay. Okay, good. Well,
Light.
one more quick one for practice on number 34 in the same section.
It was like that one time you showed me a sine graph, Miss Klinger, and it just destroyed my world. I was like, it is a unit circle. Crap and all. And you didn't even.
What are you doing destroying worlds over there, Miss Klinger? I always knew as a math professor that my job was to torture students. I didn't know it was to destroy worlds too. I mean, that's
Destroy worlds.
That is the new job description. We can't
I
predict
just
the
wrote
planet.
down the wrong.
Yes,
I did. I just wrote down.
It's okay, Tate.
It's not okay.
Well, I mean, it is, because you can just rewrite it.
No, because this eraser sucks.
Oh, crap, y'all.
Guys, we can't forget planet gases.
What?
Planet gases.
Oh, yeah, planetary and gases. Okay, is it going to be natural log or something funky?
Oh my.
observation. Again, the first step is just to recognize that we have to first find an antiderivative of this. And so the next step is to start thinking derivative of what gives me that. So Renzo said something about natural log. So let's attempt that real quick just to see what happens. So natural log of 4 minus 3x, if we did the derivative of that, recognize that the derivative of natural log is 1 over whatever the input is. And that's 1 over 4 minus 3x. But
there's a Heim.
Times negative 3.
A Heim rule times negative 3. So if I divide that to the other side like we did a moment ago.
What, are we going to have to do a 1/3 on this? Like negative 1/3? Is a
Now
fraction?
with me?
Yeah.
So derivative of the inside of this is negative 3 by the chain rule. And then to get the antiderivative of that thing, I've got to get that by itself. So I got to divide the negative 3 to the other side. This is going to be negative 1/3 of natural log of 4 minus 3x calculated from 2 4.
Is this going to be funky too? Please. Please.
Oh, let's see. This is negative 1/3 of natural log of. Oh, wait a minute. Oops, we made a mistake, folks.
What is it?
Thank you.
No.
It's supposed to be
Is it gonna,
You can't pull.
absolute value. Remember we had that discussion about.
I knew it.
You knew it. We had a mistake there. We had the discussion about your change in the domain. Your original function up here did not have the same domain restriction as the natural log does, so we have to force that restriction. Okay, so what does this become then? Natural log of absolute value of 4 minus 12 is absolute value of negative 8, which is 8. So that's the log of 8. Minus negative 1/3 natural log of absolute value of 4 minus 6 is absolute value of negative 2, which is 2. So,
Got him. Got him good.
good with that? So this would be like negative 1/3 of, I'm going to factor out that, make it log of 8 minus log of 2. And that's just too messy. I mean, I know we all feel happy there. I'm not quite happy yet because it is Wednesday after all.
Huh?
You get happy when it's Friday, right? So, on Thursday. Yeah. So by log rules, what can you do to simplify that expression?
Oh gosh, I don't want to think this through. What is it? Crap, what is it?
Is it log of 6?
It's going to be the log of 8 over 2,
Oh,
which is simply the log of 4.
I've never been much of a log man.
You can even do one more if you wanted. When you multiply by a negative 1/3, that's equivalent to using it as an exponent. We'll just leave that. I'll be happy. It's almost right now. Okay, so there's 3 good examples for you to work from as you work on the homework in section 4.5.
Wait, would that be the final answer?
Question?
Besides.
Okay, so,
I got, I can see that, but I got negative 1/3 times log of 4.
Would you just keep it like that?
okay, so you want like exact answers, right? Not decimals.
Right.
Okay.
Okay.
Got him good.
Any other questions on these? So you do need to practice. Obviously, the application of fundamental theorem is not that difficult, except the one step that is difficult is finding the antiderivative. But if you develop some good practice habits with that and begin to see derivatives, you know, when you look at this, like Razor said, well, that looks like the derivative of natural log. If you think the derivative of natural log is 1 over something. Or when you looked at this one, that looked like the derivative of something involving inverse tangent. So if you recognize those derivatives right away, then it's not so difficult to find the antiderivative, although sometimes you do have to try something, guess and check, we call it. Try something and see if you can get it to match up precisely. Okay? So I'm going to try let's try one more just for.
Can you do 21?
Can I do 21? I'm going to say yes, I can.
What? I could not.
Okay.
Last night.
It's almost Friday, so I'm already being smart. Okay, so number 21. We want to try 21. Wait, that's not a whole time? What is it? 4.5, number 21? What is it? Integral of what? F integral of from what to what? 3 to 4. Oh, it's 1 to 4. 1 to 4 of 3 times 2 to the x dx.
In respect to x, or as I say, dx.
Okay, so now what?
Are you gonna move out the 3 by constant multiple thingy?
Yes, we can do that, certainly. So this would be 3 times antiderivative of 2 to the x, respect to x, evaluated for 1. So we can use the constant multiple to pull the 3 out of the definite interval, and then at the same time, I went ahead and converted by the fundamental theorem to an antiderivative evaluated at endpoints.
So it would be 2
And
of x.
really, 2 theorems went into play there: the multiple theorem and the fundamental theorem. Okay, now what?
Log of 2.
Do you remember that the derivative of 2 to the x is equal to it's 2 to the x times natural log of 2. And that's not a chain. That's not a chain rule. That's just simply the fact that it's not a base e, so that natural log of 2 comes in to modify that exponential function because it's not a base e function. That's where that natural log of 2 comes in. So that's part of the derivative of 2 to the x. If it had been 2 to some function of x, then you would have had to do a chain rule, but there's no chain rule involved. That log of 2 is just simply based on the general property of derivative of exponential function. But that's not what we're dealing with, so I need to divide by log 2 here. So this becomes 3 times, and then I got to divide by log 2 to get to the antiderivative. So this is going to be 1 over log 2 times 2 to the x. 1. Follow that now? So once again, reading in reverse, like we did over there, if I divide this to the other side, and then read in reverse, I've got my antiderivative. Let me take that one. Let me just do that. I've been saying, but I'm not sure. Okay. So this is equal to the derivative with respect to x of 2 to the x. If I divide both sides by natural log of 2, I can pull that constant inside this, so I get d by dx of 1 over natural log of 2 times 2 to the x equals 2 to the x.
Can you differentiate that to show that's the case? Because wouldn't you get a product? Would you get a product rule or something if you were?
Well, you could get a product rule, but that's a constant. So I could just use a constant multiple rule.
Okay. Okay.
Now, to really show what's happening from here to here, let's do an antiderivative on both sides. Let's go in here and put the antiderivative of the derivative of 1 over natural log of 2 times 2 to the x with respect to x equals antiderivative of 2 to the x with respect to x. If I just apply an antiderivative operation to both sides of that equation, antiderivative and derivative now cancel one another, and I just get 1 over log 2 times 2 to the x equals antiderivative 2 to the x dx. So I hadn't actually done all those steps. I kind of just talked it, but hopefully now you see all the steps that if I know this derivative, I can back my way into the antiderivative. Okay. Now we're almost done. That's done. 3 times 2 to the 4 is 16, so 16 over log 2 minus 2 to the 1 is 2 over log 2. I guess that must be 3 times 14 is 30, and 12 is 42 over log 2. Something like that.
Wait, hold on. How did he get 42?
14.
16 minus 2 times 3.
Is it zoomed in enough where you can see that?
Mm-hmm.
42 over log 2. And or the, again, spelling out in more detail the thinking that we've been discussing, trying to show you the full detail of getting to, I now have a statement at the bottom of this column that explicitly states that the antiderivative of 2 to the x is this. And this is there. Okay. So I think you should try one more too. While we're trying one, how about number 57?
Yeah. Yeah, I'm good.
Okay, 2 minutes on 57. See what you can figure out, and we'll talk about it. A more challenging one.
You're right. It is.
Question.
Oh gosh, I got it.
Or
Oh, if it's inverse tangent, it won't be log.
Yeah, I got one. I don't know if it's right.
Good question.
I got it.
Joe's asking the question: is there some relation between doing inverse tangent, and logarithm? And there is a similarity, but they're not identical. So, if you had, for example, the derivative of the log of 1 plus x squared, if you had that derivative, then you would get 1 over 1 plus x squared times the chain rule derivative is x,
The plane of a tangent.
which would be written as 2x over 1 plus x squared. That looks a lot like inverse tangent, but it's not. Okay? So hint, while this one sort of almost looks a lot like inverse tangent, you know, if you thought of it as your x was negative of x or something, you know, somehow you might try to fit it, but it's not because you got this extra piece up here.
Okay, Chloe.
So instead of doing 1 plus x squared, let's go back and change this to 1 minus x squared. So we'll put 1 minus x squared in there. And this is going to become a negative 2x multiplier like that. that's sort of close to this.
Yeah.
How can I convert this to look exactly like that? By the same idea, dividing by a number, or what can I do on both sides of this equation? So once again, just to summarize, I got derivative of natural log 1 minus x squared is equal to negative 2x over 1 minus x squared. But I want to get it to look like that. I need a 3 there instead of the negative 2. How do I make a 3 magically occur? Well, you could add a 5 to it, but you can't really do that because on the derivative side of things, you can't bring a plus 5 in. But you can bring a multiplier. Instead of adding 5, let's multiply by something or divide by something. What would you want to multiply by?
Can you multiply by a negative 3/2?
I think that would be exactly perfect. So if we multiply by negative 3/2 here, times negative 3/2, and times negative 3/2 here, then that's going to give me a 3x over 1 minus x squared. This is going to give me the derivative of negative 3/2 log of 1 minus x squared. So now we'll do the antiderivative. You've got it. So this, now you're ready. It's almost done. This is the antiderivative of 3x over 1 minus x squared with respect to x from 2 to 4, which is, we just determined the antiderivative is that, negative 3/2 natural log of 1 minus x squared from 2 to 4. Now it's all absolute value.
You have to do absolute value again.
Yes, you do. Thank you. Again. I did something.
Curse.
I remember. Okay, so I think you can finish evaluating that one. Save a little time, let you do that at home. Let's try one more, at least. Lock in this. How would you do, how about 42? How would you do 42? I don't know. I haven't looked at it. There could be. It definitely has a fraction involved.
Hang on, I'm feeling something.
It does have a quotient appearance, but it doesn't seem to me to really fit directly a quotient rule derivative. This has to be g of x squared if it's a quotient rule, and then that has to be the derivative of it somewhere. I think it's gonna. There's a much simpler way to handle this problem. Much simpler.
What is it going to be? Factor out an x or something like that?
What's the suggestion?
Is it going to be factor out an x or something?
No.
What do you mean? How you?
You know, pretend I didn't say it. I changed my mind.
I mean, possibly, as long as you don't mean factored outside of the definite interval symbol. Within the symbol, inside of it, you can do whatever algebra you want to do, as long as it's legal algebra. But you cannot pull an x out of the definite interval. You can pull a constant number out, constant multiplier like 3, not an x.
Algebra is like sorcery. It's like magic. I'm so close.
You suggestion that could simplify this, make this easy to do?
Yeah.
It's legal algebra.
Somehow.
I don't think you can split it.
Maybe you could multiply it by 1 over 2x instead of having a fraction or something like that. I don't know. Wait a second. What if that is the case? Oh my
Oh
gosh.
yeah, you can split it, because you can do x squared over 2x.
Oh dang, y'all.
Other
We balling. I mean, that wasn't how I was gonna do it, but you know what? I'm okay with that.
So this is simply comes down to 1/2 x plus 5/2 x to the minus 1.
Got him. Got him good.
Notice I went from a fraction over 2x to a coefficient times x, negative 1x1. That's easy to find an antiderivative of. What is the antiderivative?
What is the antiderivative?
One fourth of x squared.
Where's this coming from?
It's the very beginning of when we started.
Okay. Okay. What? It's gonna be like x because you're gonna have to subtract 1 or something? Oh gosh. Freaking out, guys. Was it gonna be x to the negative 2 or something?
Yeah.
You
Gosh.
It's n plus 1.
How did you get 1/4 x squared? Tell me that, right? Real quick. How did you get this?
The 1 over k plus 1 times x to the k plus 1 thingy.
Okay, that's right. So we went from 1 up to 2 and divided by 2, which gave me 1/4.
Will the next one involve a
It's
natural
gonna be an
log?
x negative.
Go up to 0 and divide by 0. What? Or,
A natural
I
log?
don't know what I'm thinking.
yes.
Dang, Sammy's on top of the world right now. Oh wait, it can't equal negative 1. That was the exception to the rule. Whoa. Dang.
Questions right.
You're on top of the world.
I don't think I've gotten this many questions right total in this class.
I think you're wrong.
Oh, this is trippy.
It's trippy.
We're out of time. Homework,
Get that one.
practice, and then practice twice more. You need to be able to do antiderivatives fairly quick and efficient. Again, that requires your knowledge of derivatives. So make sure you study your derivatives and remember all of those so you can spot the antiderivatives for you.
You got him good.
Tomorrow.
Hey, Dale. Oh.
He's gone.
So
What are you gonna ask him?
So on that last question, could you have pulled out of negative and then switched
Switch it so it was
to the negative 3 instead of negative 3 to 2?
To negative 3 instead of negative 3. So we never did
And then it
circles.
would have the derivative on top,
We
and
never
then it
did
would be a
what?
natural
I've never
log.
done one like that. Really.
Yeah.
A lot of negative and flip.
What?
I'm confused.
Algebra's just like circles. And then there's like a flip.
Let me show you.
Alright, you show us.
I'm just asking. I don't know for a fact.
Well, I don't know if I'm right either, so.
All I ever wanted
So
was just
tell me if this is the same thing he got. I don't know. Did you actually calculate that?
Nope.
He didn't finish it, but here's what I got.
So if you pulled out the negative, right, then it would switch it from 2 to negative 3.
Yeah.
And then it would be 2x over x squared plus 5.
We used
Would
to
it
look
though?
at us
I thought
for-
it didn't switch the
Oh,
thing in
yeah.
the middle.
We're progressive in how we teach our classes. Something like that.
I don't know.
Even though he teaches.
This is what I got as my answer. It's not simplified, but
Which is really weird.
Hey, Razor, did you guys take the Spanish test on the?
No,
Nope,
they're
we're doing
taking
it.
it
Oh,
today.
but you don't have like.
Wait, when are you?
Ready for college.
Well, yeah, I just
They
have to solve
announced
it.
it to everyone yesterday.
No, no. I think about that.
Okay.
I'm gonna stay down.
Alright.
Are you gonna help?
It's gonna be under.
I don't know
I
how
have
I'm gonna do, but I'm sitting in the room
Well, I
because
have-
she's not here today.
It'll-
And
I have to do some research on what I'm gonna say in my MIT interview because I have a practice interview with Mr. Catholic. And he's gonna ask me questions I don't know the answer to.
Oh,
See, the correct response, Sammy, is to respond with another question. So how are you qualified? Why do you want to know?
how
I'm
are you
qualified?
qualified to be?
Why do you want to
be
know
a
I'm
mission
Just
qualified?
making sure you don't have to go on any interviews for your college, right? Because if you start answering their questions with questions, they're not gonna be happy.
Chapel Hill just wants you to apply.
Chapel just wants your money and your soul.
You
So they
guys,
ask
we
you-
need to figure out what the calendar for that final exam week is because I think that you have to be here.
We do. We're here
We do.
Final exam week.
all week.
And
during
then your
this
final
period.
is the
Really?
Wednesday,
The last
Thursday?
2 days, yeah.
Yeah.
It's
What are
the
we gonna
13th
do
and the
then?
14th.
Review.
So I gotta make sure.
And the 2 days
Because
before
I
our
gotta go
review.
to a final on one of those
Or we
days.
could just go. Oh.
I have a question.
I mean, I just have some.
Is it gonna be 2 straight days of testing, or is he
Yeah.
going to do something
It's 2
different?
straight.
How long are the tests?
The
I mean,
final?
the
The
Yeah.
final?
I'm
Have you
assuming longer than a test.
have you
It's
seen how
2
long our
parts.
normal tests are?
I mean, is it just gonna be like 2 normal class periods length? So just 2 hours?
2 hours.
So 2 1-hour sessions. I mean, it's not that bad.
No, that's
That
bad.
just expands our time frame of torture.
Well, it also
Well, you can't go too
you
many
also
depths.
could go home on the first day and be like, okay,
And
I
it's gonna
have
be 2
no
different parts.
idea.
They'll split it like part 1 and part 2, and once you
Yeah.
turn in part 1, you can't get it
Or
back.
you can like,
Oh, that's
you
true.
can use the microphone, put a piece of paper over the camera, and then discuss all
So we're having technical difficulties. Sorry.
Whoops, sorry, y'all. the
Which
connection's
day are you gonna
failing.
be out
They
for
wouldn't
testing?
find it the least
I
bit
don't-
weird that we put paper
I
over
can't
the
remember if my
camera.
Wednesday
Whoops,
test
y'all,
is
technical
in the morning or
difficulties.
afternoon.
Okay.
Is Miss Claire conspiring with the Davy campus?
Our
But it's
Phoenix
like,
Friday
we
is
learn
just
so
a
much
big study
information.
hall.
I know.
don't
I'm
know
actually
where
like
to start.
I actually
ready
don't
for
think
it
it's
because
No.
I need
It's like-
it.
it's
I have
what,
so much
limits?
stuff to do.
But then you have-
Derivatives and integrals,
You
basically.
have so many rules for each
Yeah.
thing.
Yeah, that's why you take them all
I would
your
know fundamental theorem of calculus.
Wait, what?
At the very least.
I won't
I
finish everything.
guarantee that will be on your phone.
What if it's not on it?
Fundamental law of this class. You
Yeah.
better know that.
It's the
Yeah.
central
It's like
legislature.
algebra if you don't know the fundamental theorem of
I don't know the fundamental theorem of
What is the
algebra.
fundamental theorem of
A squared plus b squared equals c.
Oh.
I'm
No,
just
it's
kidding. I don't
basically-
know.
What was it? The
It's-
f of a sub k
It's
minus.
very similar to the mean value theorem.
Yeah, that's what I thought.
I just hope on the exam he doesn't say using the specific thing we look like. You know how in each unit we learned how to do it and then we learned the easier way to do it? I don't want him to put on a problem to do it the harder way.
It'll
Yeah.
probably be explaining.
Here's what
that.
you do, y'all.
Do you
You
think
look
he's
at.
I
gonna
thought it
read
said
one of our
multiple
test
choice.
questions?
It is multiple
Yes.
choice.
I thought it was.
Hey, that's pretty good.
All
Yeah,
I'm
but he's
still
gonna
not
put
gonna
the
do
hardest
well.
questions on there.
And there's no partial credit.
Okay, let's not get too excited
Yeah,
because
no
the calculus
partial credit.
exam that we took at the competition was also multiple choice.
Well, also that was
story.
I got
that
9 out of 40.
That got Calc 2 on it too.
I know, but
That was like 5
Okay.
questions of count two.
so how many? Who got the most questions right on the?
Carson.
Probably
It was
How
me
many
and
did you
Carson.
get?
Carson.
Excuse
14.
me. It was
Okay,
me,
14 out of
too.
40. I
Oh,
doubt
11.
the other.
But the
rows
way
all
the
have to.
competition works, like if we would have had Mason there,
We would have probably.
speaking
done
of which, he has still not talked to me.
Yeah, I know.
If we had had Mason there, then that would have bumped you guys up to more overall points, and you probably would have been higher.
Yeah, because I saw
What the
this.
heck?
There was a big.
I
We
saw
just
this
had to be
marked
struck
as
with
zero.
illness that day.
Yeah.
The worst.
Yeah.
Yeah.
So we had 0
How
points for
dare
that.
you.
He
So
should've
you
just
could have
come
been
sick.
in at least 3rd or 4th overall,
Oh.
because you were
I don't
5th
know.
overall.
We would have gotten a trophy.
Or medals.
I would have
I don't
taken
know.
a medal.
Overall would have been a team trophy.
I would have smelted my
You know
metal.
We
what?
would have had a team trophy.
Oh my god.
He
He should have just come sick. I don't care how many people he infected as long as we won.
He should have at least come to the door when I was banging on it.
Yeah, he
At
said,
the very
he
least.
said he heard it. No, he said he heard it,
He
but
said
he
he
just went back
didn't
to sleep.
hear it.
He told
Oh
me
my
that he
God.
heard it, but he just went back to sleep.
Lisa, no.
I would have smelted my metal into
Did
like
you guys
golden
not check under the
calculator.
mat to make sure there's no stairs? You can just come in.
Hey man.
Mason, get
I mean, he tried to call Malcolm to see if Malcolm could take his
Oh,
place,
yeah,
and he
man.
was working.
Oh my.
Back up, y'all.
That is the saddest thing.
It was fun, y'all.
I mean, we could have just gotten somebody off the street to come in and just.
Because honestly, they
Answer
were just as good
questions.
at guessing as I was.
Yeah.
Yeah, who would we have chosen?
I mean, Dylan
Mr.
guessed
Bruff.
and he got 5 right. So.
Let's get
Hey,
can
I
we get
got
Mr.
five.
Bruff on our team.
That's
I got 9 right.
I would have loved to have Mr. Bruff or Dr. Gordon would have been really good at our
You
team.
can't have over an AS degree. You have to be working on an AS or AA degree.
I'm working on an AA.
I'm working on both. I don't know if
Same.
I can get either.
I mean,